Perfect. Hello everyone. Today we are going to explore how to write Rust macros to get rid of the cursed boilerplate. This workshop implies some familiarity with Rust programming language, but even newcomers can get something useful out of it. If you've programmed in Rust for a while, you definitely must have seen something that looks like these three lines. Each of them corresponds to a kind of procedural macro, ordered by their power. However, all these lines could correspond to some other things, which we will probably discuss further. Today we will also mention some of their overarching principles and implement each of the three kinds of procedural macros one by one. And that's a lie. Probably we'll have time only for the drive macro.
Awesome. Am I supposed to be able to see your screen?
Sorry?
Am I supposed to be able to see your screen?
I think so. I think so. Give me a second. Haha. Apparently, I effed up terribly.
Nailed it.
First, we'll start with derived macros, because they are, in my opinion, the most useful and the most commonly used kind of Rust macros. And we will start by solving a real-world problem that one of our members, Alex Wilkinson, proposed. He discovered an awesome trait, validator, that offered a convenient derived macro, validate. In this case, it implemented a validation of the struct fields by checking against some regular expressions, like here. There was some regex, another name regex, and a phone number. Syntactically, it was done by adding validate to the list of derived macros, and that should be applied to the struct. And by using the lowercase validate helper attributes with the corresponding arguments. At the time, I hadn't delved into the source code of the validate derived macro, but I did know that it somehow implemented a validate function for the user settings user update struct. Whatever. As lazy as I am, I requested him to provide a macro expansion for the validate derived macro because, firstly, I wanted to show that derived macros can spare us from writing a ton of boilerplate code, and secondly, I wondered what kind of code did the derived macro generate. Soon, you're going to see that my phrasing led to some confusion, but while I was waiting for Alex's reply, I checked out the documentation of the validate trait, and I found the trait that validate derived macro implemented. As one could expect, the name of the derived macro matched the name of the trait, and this trait contained the validate function. So this will be like a story, so that you could actually understand what was going on, why we are going to write, what we're going to write. If we look at the snippet of the code again, we can notice that in case of any validation errors, the snippet immediately returns the corresponding variant of the user setting user update error enum for any of the field errors, or returns the unknown error variant of the enum in case of non-field errors. After reading the documentation, I also didn't quite get what kind of errors could be encountered. Maybe having an unknown error variant was both justified and practical. However, if we want to eventually generate a function based on validate, we need to better understand the validation errors type. I checked the documentation of the type and I was disappointed. I had to read several, if not all, methods of the struct in order to have a better understanding of the struct. The crate was, for the most part, documented, yet the documentation didn't match my expectations. For example, I didn't know that README contained the documentation for the items that didn't have those comments. As a result, I had to jump extra hoops to get the work done. At least it's open source and we'll try to make it better. Let's take a quick look at README. That's the README of the validator. So Macros 101 custom derived macro to simplify struct validation, inspired by Marshmallow and Junk validators. The minimum number version installation, and a short example. just like we have here, derive, validate, deserialize, and some validation here. All nice and dandy. And here the use of validate. And we are not going to read it all. I'll actually skip to the important part. According to README, in this example, where we have only field variants, any validation errors returned from validate would be of kind field. In other words, for any instance of validation errors that could be returned from the example, if we apply function validate errors, the only possible validation errors kind would be field validation error kind, whereas the other two errors responsible for two other kinds of errors of validation, whereas other two errors are responsible for other two kind of errors of validation. Struct validation errors could be returned for struct with nested structs, and this validation error could be returned for a vector of nested structs. In this case, it's a vector of preferences right here. So we have a vector of preferences, and we validate every preference in the vector. As a result, we get a list. Now that we sort of understand what kind of validation errors can be encountered in general, let's start tackling the problem of simplifying the code that we saw by writing a simple derived macro that would just generate the declaration of the validation error type for the type to be validated. Further action will take place in the GitHub repo for the workshop. Some scaffolding has been made in advance, but the actual validation will be created live. So now we are going to see some commits to the repository that I made beforehand, and I try to make them as easy to comprehend as possible. So first of all, I created a workplace. Workplace is basically a collection of crates that share common compilation cache. This just allows them to reuse the same build artifacts, and it speeds up compilation times and makes the whole collection of crates so work together better. It's just there is less dependencies, binaries, all stuff that could make the project heavier. I added a simple macro workshop. I added a validator extra example crate so that we could test how our macros would work. It was a simple hello world that was generated by cargo new bin, and I scaffolded the workplace by creating new projects. There were, in the end, we ended up with three traits: validator extra example, validator extra core, and validator extra macros. This goes in line with I will provide the link is provided with the recommendations by the author of any input. And here's the link on Discord: 9 rules for creating procedural macros in Rust. I highly recommend this article. It is by Carl M. Cuddy, and it offers lots of nice tools, a lot of good practices, and and the division of these crates, like why we have 3 crates, is one, we need a crate for an example of a downstream crate that would use our derived macro. One crate is going to be the responsible for providing macros. It will be a proc macro crate, first macro lib, and another is going to be a crate that will actually provide will actually implement procedural macros using a workaround proc macro 2 that allows to actual test macros and the main essence is just test macros. That's the main benefit. So after that, here is an example of validator extra macros of the simplest proc macro crate. If we browse files and go to validator extra macros, it will be just a crate. So there is cargo.home. And what's special about this crate is that this crate has a special field. It has a special thickness manifest, special field, I believe. Is that how it's called? Field? Or lib. And we set proc macro to true. This way we make this crate a proc macro lib, which is basically a dynamic library that will be invoked by the compiler as it compiles our code and expands the macros. So, and if we continue, go back. It is the simplest implementation of a derived macro. So we used proc macro. This crate is the standard crate that is available for proc macro libraries. We can look it up. Proc macro Rust. It is a support library for macro authors when defining new macros. This library is provided by standard distribution, and it provides proc macro attribute, and proc macro derive attribute macros. And this way we can write macros. But what are macros in essence? These derived macros are some functions that read the source code of the item on which they are to which they are attached. Like in this case, proc macro derive is an attribute macro, and it is attached to this function, derive validation error type. And this attribute macro can see this syntax. PubFN, all the syntax is visible to this attribute macro. And talking stream, we read, so we can read this syntax and add new syntax. So derived macros basically create new syntax based on existing syntax, and it is great because in this case we can just like in case with validator crate, it allowed to generate the boilerplate for writing for validation, which is great because I checked the expanded version of the macro that Alex sent me was, I believe, 56,000 lines of code, which was insane. And it's great that it saves so much typing. You don't have to type much. And this error crate exactly like this. It is a derived macro that allows to make the life much easier. But coming back to the task, we want to have a derived macro. And what is this attribute validation error type? We could see that validator had this weird where is that? This weird validate, lowercase validate. These are called helper attributes. And these helper attributes do not do anything on their own. They are there to be read by validate macro. And the way we express it, we add attributes and in parentheses the name of the helper attribute. So we will be able to write something like validator, for example, just to be able to write some code, something like struct, my struct, fine enough, derive, validation error type, let it be, and validation error type, and my error type. That's how more or less we would be able to use it. We would be able to use this attribute, and we would be able to read this attribute from the derive macro. It exists here so that we could annotate our fields, our types, and essentially provide information for the derived macros to generate useful code. And there was an example where I tried to add a test in the validator extra macros, our proc macro lib. I tried to write a test and it didn't work. Why? It didn't work because, as I mentioned, it's the compilation target, the build artifact for this kind of crate is a dynamic library that would be invoked at macro expansion, and it is not the same kind of code that would be that could be generated together with tests, because they have different notion of compilation target, because macros target the host machine, not the target machine. So if we do cross compilation, macros expand on our machine. As a result, they compile for our architecture, for the architecture on our machine, and not the architecture on which it will be run, because it happens at compile time. Tater doesn't seem to understand what I express, and please ask question.
So, would that mean that a macro could potentially expand differently based on your architecture?
Sort of, yes.
Could you check in the macro? Could you check what the architecture
Yes.
was? And
Yes.
Okay.
You can do crazy stuff. The same goes with. So it is possible to do with CFGs. Give me a second.
Now, I think that the fact that it will ignore that when you're cross-compiling would be annoying. If you were to have, say, a performance optimization in the macro for a particular architecture, if you do cross-compilation, you would be screwed because
it's slightly there is like basically you will need to query the compiler. There is like println rusty, something like this.
Okay, I see. So there's a way to do it.
Yeah.
But you have to think about that in advance. If you use the standard feature set, you might.
No, if you use CFG and like regular
CFG and target.
If you do conditional compilation, it will use actual compilation target, not the cost. But the cost or the actual but yes, that's where it's tricky.
Yes.
And that's why proc macro libs are special, and they just usually are separate crate.
Yes, they have. Rust won't let you export anything other than a macro.
You can export macro, but it is a different story.
Right. Okay.
Right, and we have approximately 4 minutes, I believe. We can be. I don't think anyone's scheduled after us, but we will need to just move outside, and we will actually write some code there. The presentation is nearly over, and then we actually will write some code together. First, product marker workshop, and we need commits and demonstrated how to do testing. So there is a problem. We cannot write tests in the same crate as product macro lib for this reason. And what is the solution? Have another crate, and in this another crate, we will actually implement macros, but and basically we will use not the library, not the built-in library, proc macro library, but its version that can be run outside of proc macro crates. This library is called proc macro 2. It is slightly more stable than proc macro library. So proc macro is permanently unstable, but it is used nonetheless, and you can use it without unstable features. But the API changes and breaches can and will happen. But I think it should be alright. Because it only affects things like fun and like there are nightly features, and this like the implementation you cannot rely on it. That's the essence. So you so in order to test, you move the implementation of the actual implementation of the procedural macros into another crate, and in this another crate you will most often use scene, proc macro 2, and quote. These three libraries are the most these three libraries are the holy trinity of proc macros, and I will talk about them one by one. Proc macro is basically the version the version of proc macro that can be run outside of proc macro lib, and quote is a kind of crate that allows you to conveniently write conveniently create AST, abstract syntax tree of Rust. And the way it works, so we have an input, so we have a variable input, and we the expression here is the quote and the struct. And the result of this is a token stream from proc macro 2. There is like lots of magic. This stream from proc macro 2 can be converted to the token stream from proc macro, and we can implement functions derive validation error type. Like it's the same derive macro implementation. Just the token stream here is from proc macro 2. So essentially the same implementation, just different types. Here we can use we can write tests, and we actually can do crazy things in here. So we can do even pretty difference here with colored output, so that we can see like diff version of the macros if they're not equivalent. So and that's basically where we basically go outside of the actual path and start writing our own stuff, our own derived macro. So for that, we will need scene. Scene is a parsing library for parsing a stream of Rust tokens into a syntax tree of Rust store. There are different kind of items that we can parse. We can parse item fn, item fn, simple item fn, which is a function. So a freestanding function. So there is fn. There is where is attribute visibility signature? The function has some attributes which are like hash and then stuff in square brackets, like this. This is an attribute. There is visibility, which is public or restricted or inherited, and there is signature. And in this signature we have constness, asyncness, and safety, ABI, which is like externcy, FN token, like this FN token, and ident, which is identifier, which is the name of can be the name of the function. There can be generics, maybe some parent tokens, and inputs. And scene is both a good way to actually learn the syntax of Rust, because you can really know the syntax of Rust because you are operating on it. You code using it. And secondly, it's a good thing because you can very conveniently parse stuff in derived macros, in other kinds of macros, and write pretty nice code. So I hope that no one is waiting outside. No one is waiting. We can be here. We can stay here without any worries. And let's actually start writing the code. Where we stopped. So the problem, we want to create a macro, derived macro that would generate an enumeration, an error type for different kinds of validation errors for every field. So this enum will have a variant for every field. And yeah, I'm sorry. Are you following? Are you doing something else? Like, please, I would like to hear some feedback.
Yeah, I'm following. One of the things I'm curious about, so with most of the macros that get derived with like sin, is that like they're all just kind of parsing Rust code back into like some kind of syntax tree that like Rust uses for its lexer or whatever? Like,
yes.
And that's how most of them work, or all of them work?
Yes. So Proc macro. We can work on with token streams, which can be converted into iterators over token trees.
So is it kind of like Rust itself is just one kind of giant macro that parses in the same way, and these are just kind of like callbacks almost in a weird sense or like hooks almost into the system that reparse stuff.
Yeah.
Is that kind of what's going on there?
Yes, but only nearly in the same way, because macros, by example, are slightly different. They're weird. There is a section on that in Rust reference on procedural macros. So if we open Rust reference, there is procedural macros, function like macros, derived macros, attributes, and there is a part declarative macro tokens and procedural macro tokens. So the tokens are slightly different. In tokens in macro rules have delimited groups, and they support, for example, they support multi-character tokens, but Rust procedural macros do not support them per se. They sort of do. They have a thing with spawning, but it is another topic. It is quite advanced, and because it has to do with hygiene and other things that are quite complicated, and it would be basically like it would take a week to tell the whole story, and there probably will still be many gaps. Literals here will be fine, but I don't remember and floating point literals, but I believe is never not the negation is never part of such literal tokens, but a separate operator token. So it is a slightly different notion here. There are other like idiosyncrasies and minor differences between procedural and procedural macros and macros by example, but they can be useful when you want to do some tricks with them and make them work together. But unfortunately, I don't have a good example at hand, and I don't think I can concoct one live. I'm sorry.
All good.
But yes, we operate on Rust operates on abstract syntax tree, and we as Rust programmers have access to it via procedural macros. Yeah, I shouldn't have 9. There is a good tool, 9 rules for creating procedural macros, and there is AST parser, I believe, abstract syntax parser. It is not Rust specific. AST Explorer, which allows to see different code. Let's snippet JavaScript. Let's select Rust. And we can see what kind of structure does syntax tree have. So there is item const. So there is a constant, and this constant we have. Let's expand it. Let's expand it. We have visibility. Wait, where's the visibility? There is no visibility. It's inherited as a result. Like no visibility means it's inherited. Const token. There is ident, which is tips. There is colon token. There is tie, and eventually, if we unfold it, it uses the procedural microinterpretation. There are slightly different ones for, as I mentioned, for Marcus-Beck example, that's slightly different, but these are the most common kind of token trees. And when you talk about Rust abstract syntax tree, you usually mean this kind of syntax tree. And they have Scene is so popular. It is, I believe, #1 installed crate on crates.io, and it is followed by by quote and proc macro 2, I believe. So these things you can sort of know that item const it is item fn, type reference, x reference. These things are quite standardized, and as a result, you can think in these categories, and it can be quite convenient because you can actually create really good code. And if you take it one step further and use Rust Analyzer and do actually type analysis and some shared memory magic, you can actually make macros with mutable state, and then you can have full introspection using macros. It is not implemented yet, but it is a possibility. and I'm looking forward to someone actually implementing it. I'm too lazy to be the one doing it. But yeah, I hope I addressed your question and I didn't talk and ramble too much.
Yeah, totally.
Now we showed AST. What kind of AST? It is like indeed a tree. There's like stuff inside stuff. There is like
Is that the actual like Rust AST, and then the macro one is slightly different, but like kind of close, or?
yes,
Right.
yes.
Okay, gotcha.
In order to see what the actual AST is, token tree Rust. And token tree in Procedural macro is either a group or identifier or punctuation mark or a literal. And a group just is you can get the string inside of it. And a group is one of the parentheses, square, braces, or square brackets, one of these things. Identifier, punctuation, plus, equals, star, literal, string literal, or number literal, all these things. And that's more or less what it boils down to. It's just a sequence. Token tree is just token stream is a sequence of token trees, and we can iterate over them using Intuitor. So if we go token string, it implements Intuitor. Token string, yeah, yes, that's the Intuitor. But I was looking for token string. Into iterator, and that's where there it is. And it implements into iterator of type token tree. You also can clone it, and the cloning of token stream is cheap because I do not remember it. I believe it is interned, and as a result, you basically move pointers to pieces of the token tree. So you can clone without any concerns. It is fast. Let's explore and let's actually start writing the code. Because I want to help Alex.
I can't actually see your VS Code for some reason, but I'm not sure
yes, because,
why.
Sorry?
I'm not sure why, but like your VS Code doesn't seem to show up on the stream.
Oh, it doesn't?
Yeah, it's weird. Like I can kind of like tell you're in it, but it just like seems to be just the like web browser.
Let me see.
You might be sharing a window.
Yes, that's what I thought about. Thanks for the idea, though. It's a really good idea, I believe. And perfect.
Oh, there it goes. Okay, awesome.
Because the library is closing in 15 minutes.
It's closing in 15 minutes. That's why. I see. All right. Probably we'll have part 2 eventually. Right. And let's at least write something. So token stream, and let's parse this token stream as it must be a struct. All right. Let's do just struct like this, and parse input. Wait. Use scene. So use scene parse. Wait, do you write parse? Wait, parse input, I believe. Parse input. Parse macro input. Let's ensure that is the macro that I was looking for. I cannot ensure. First, macro input. Let's check the item struct. I believe that's how it. Awesome. Have similar token stream. They have similar names, but the parse 2, I believe. Parse 2. Parse 2. Good. I apologize because okay, parse 2. Let's ensure that it's the function parse a process macro token stream into the chosen syntax string. Now, perfect. Oh wait, right. Parse derive scene. I already forgot. Derive scene parse. Derive markup. Scene parse trait. There is scene. Oh, I want to ensure that I use the right one. There is parse. Now, because derive input and derive input, parse macro input as derive input, parse macro input, and here macro input, macro input, derive macro input, derive input. I apologize, derive input. Now you can actually stop streaming because it is not a thing that is like the educational part is over now. It is like the actual.
This is what I spend most of my time in Rust doing, is like trying to figure out the right names for things.
Yes. Token stream. Wait, is it token stream or it is token stream too? Let me see. Parse. Is there parse macro input too? Is there something? Is there a thing? Is it a thing? All right. Parse 2. Let's just parse 2. Second time is the charm. Seventh time is the charm. Wait, parse 2. Yes, please. Parse 2. Parse 2. I think it's not a struct. It is derive item. Parse cannot. It's a function, but not a macro. What? Yes, it can be a function. Parse 2. Derive input. So let's specify this generic, and let's go with this. So now I believe we can do this, and I believe it's fine to unwrap here. We are not trying. I think it's fine to unwrap here because if it's not a derive item, it will probably let know the user. I rely on implementation of that. So we can, because we actually use input here, we can get rid of this underscore, which is meant to silence warning about unused variable. So with the derive item, here we need list of attributes. Derive item dot attributes, and let's find. Yes, we probably need to go now. Yes.
We will have a part 2.
Yes.
Part 2.
But this is what's presented and is great.
Right. You can get code.
you.